Now let us see how to measure this heat exchange or enthalpy change using the calorimetry technique. We use this method because we cannot exactly measure the enthalpy of reactants and product. And so through the calorimetry technique, we measure the change in enthalpy. Here is an example of calorimeter we use in the normal laboratory, in the high school and college. Sometimes we use it, but this is not the calorimeter that looks like in the industrial setup and industrial laboratories. But this is a simple version of a calorimeter with a coffee cup, because coffee cup is a very good insulator which is made of styrofoam cup, right? So two styrofoam cup nested together we use to construct a simple calorimeter. So that's the instrument here shown here with a thermometer here, glass stirrer with the chemicals inside. All right, so the reaction mixture in solution is here, for example, sodium hydroxide and hydrochloric acid, and we can measure the heat of reaction using this setup. Once we have the specific heat capacity of the material, and if we have the mass of the material in the calorimeter, and we can measure the temperature change, and then we can calculate the heat change, heat absorbed or released in the reaction, okay, using the formula Q equal mc delta T. So this is going to be the total mass in the calorimeter. This is the specific heat, and this is going to be the change in temperature. Okay, so what is specific heat means? Specific heat is nothing but it is the amount of heat energy required to raise the temperature of 1 gram of a substance through 1 degree Celsius. So here you can see an example here. 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. To raise the temperature, we need 4.184 joules of heat energy. So that is the specific heat of water. Okay, let us see an example here. In a coffee cup calorimeter, 100 milliliters of 1 molar NaOH, 100 milliliters of 1 molar HCl are mixed. So we are finding heat of neutralization here, or heat of reaction here, okay? So both solutions were originally at 24.6 degrees Celsius. And after the reaction, the final temperature is 31.3. Assume that all solutions have density 1 grams per centimeter cube and a specific capacity of 4.184 joules per gram degree Celsius. Calculate the enthalpy change for the neutralization of HCl by NaOH. Assume that no heat is lost to the surrounding or the calorimeter. So first we can write what are the things given. So we know the mass is given, even though it is not directly given, they give you the volume, they give you the density. So we know density is mass over volume. So mass equal density times volume. So we can consider that is 100 grams of NaOH plus 100 grams of HCl. So total it is 200 grams. And also we have the temperature, initial temperature and the final temperature. So both are in degrees Celsius, 31.3 degrees Celsius. So the change in temperature will be 6.7 degrees Celsius. When you subtract, you can see. And then what else is given? Specific heat is given, which is 4.184 joules per gram degree Celsius. All the units are matching gram degree Celsius. And now we can calculate the unknown. They are asking calculate the enthalpy change. Correct? Okay, so in this case, we can use Q equal mc delta T. So mass is 200, C is 4.184, and change in 6.7. So the answer is going to be, when you multiply, you can see it is 5606.56 joules. Okay, 1000. So and this can be in kilojoules. All right, so Q. Now we have to calculate delta H because the question is asking us to calculate the enthalpy change. So delta H is nothing but Q over N. N is nothing but the number of moles of limiting reagent. So here HCl plus NaOH will give you NaCl plus water. So all are 1:1 ratio, and I have 100 milliliters here, 100 milliliters here. Both are 1 molar. So I can calculate the number of moles as 0.1 here and 0.1 here. So we have to go with the 0.1 because I don't have the limiting reagent there. So Q divided by 0.1, Q is 5.60656 divided by 0.1. I'll get 56, and I can just go with that answer, kilojoules, 56 kilojoules per mole reaction. The question is, if you read, you can see that temperature is going from 24.6 to 31.3 degrees Celsius. That means that is an exothermic reaction. For exothermic reaction, we know the delta H value will be negative. So I will rewrite the answer. Delta H equal negative 56 kilojoules per mole reaction, because that is an exothermic reaction. So that's going to be our answer. Let us see another type of calorimetric question. Here, a coffee cup calorimeter contains 150 grams of water at 24.6 degrees Celsius. A 110 gram block of molybdenum is heated to 100 degrees Celsius and then placed in the water in the calorimeter. So that means if we have a calorimeter and if there is water here, which is at 24.6 degrees Celsius. How much water we have? 150 grams of water. We are putting molybdenum in there. That's a hot metal now. At what temperature is that? We have that one at 100 degrees Celsius and 110 grams we are placing. And we know for water it is 4.18 joules / gram degree Celsius. This is the situation now. So we know since the metal is very hot, the heat is flowing from metal to water until it reaches to thermal equilibrium, right? So what is the thermal equilibrium temperature now is that we can take it as T final for both, that equal 28.0 degree Celsius. Okay, so here what we have to know is, we should know that heat lost by metal, okay, and which equal, because both are reaching at thermal equilibrium, we know whatever the heat lost by metal equal heat gained by water. They are equal but opposite. So heat is losing by the metal, so it is negative, and the water is gaining, so it will be positive. Okay, so when you take that formula here, heat lost equal heat gained. What we will do here, we will just look at the numbers now. So for water, we have mass, which is 150 grams, and we have initial temperature 24.6 degrees Celsius. We have final temperature 28.0 degrees Celsius, and we have specific heat 4.1 4.18 joules/gram degree Celsius. So this is gram degree Celsius. So everything is, all the units are good. And then we can calculate Q, which equal mc delta T. So mass is 150 and C is 4.18 and delta T is final minus initial. So that's going to be 150 times 4.18 times, this is going to be 3.4. So I'm going to multiply all three now. It will be 2131.8 joules. Okay, so that's what he gained by water, which is equal and opposite, right, of heat lost by molybdenum. So that means for molybdenum, it should be equal and opposite. So that means that equal negative of, what is the mass of molybdenum? 110. What is the specific heat? That's what we are supposed to calculate. And what is the temperature change? Final temperature is 28 and initial temperature is 100. So that is negative 110 times C times negative 72. So negative and negative will become positive. So 110 times C times 72. So now we can rearrange to isolate the C here. So what we have to do on both sides, we can divide 110 times 72. This side also 110 times 72. So we can cancel 72 and 72, 110 and 110, and we can get our C value, which is just going to be 2131.8 divided by 110 times 72, that equals 7920. So that is 2131.8 divided by 7920, that equals 0.269 joules per gram degree Celsius.